Hey guys, let's see how we can solve the third question from the chapter 7 of Hibbeler textbook in geomechanics. And in this one, we have two beams that are attached to the column that structure connections transmit the loads. We need to determine the internal forces, the internal normal force, shearing force, and the moment or the bending moment acting in the column at a section passing horizontally through point A. So if you try to do a section at point A, we're going to end up with three different unknowns in here that we need to figure out, including two internal forces. Can call one of them the shearing one, VA. Can call the normal force, NA, and one bending moment we can just consider for now counterclockwise, MA, and that's pretty much all the internal forces and bending moment that we need to figure out. And we are obviously in equilibrium, so we're going to use our equilibrium equations, including sum of all forces equals 0, and same for the moment. So we're going to start with sum of all forces in x directions, call our x and y in here. So at point X, we have these two 6 kilonewton forces. So one of them positive, one of them negative, so they cancel each other out, and we have VA to the left, so negative VA, and that's pretty much everything equals 0. So our VA is basically 0, which means there is no shear stress at this point. Now let's move on to sum of all forces in y direction. So we have 116 in here, which is negative. It's downward, minus 23. There's another one in here. And we have minus NA equals 0. So our NA would be 23 plus 16. So our NA would be a negative number, and it will be 23 plus 16, which will be 39 kilonewtons. And the negative sign shows that the NA is actually in the opposite direction. So that's the correct direction for NA. And the last one, we just have to find the moment about point A. We're going to call counterclockwise positive as always equals 0. And let's see what we have. So we have the moment of all of these four forces. So we have this length 250 millimeter, and A is exactly on the center. So we have 125 millimeter on each side. Let's go with the moment of the 23 kilonewton. So the moment, first of all, about A is in this direction. So we have a clockwise moment, negative. So 23, and the distance would be the distance from A to the line of action, which will be 125 plus this little distance. So minus 23 times the distance, 125 millimeter, plus this little distance, which is 40 millimeter, 40. And we can divide this by 1,000 in order to get our moment in kilonewton meter. So that was the first one. All right, now let's move on to the moment of the two 6 kilonewton forces that we have. So the moment of each of them would be, so the distance is this distance. For now, we can call this one A, and this distance is 185, and the moment of one of them is, the top one is in this direction, so the moment is clockwise, so negative 6 times the distance, A plus 185 divided by 1,000. And the second one, the small one, is in this direction, so it's counterclockwise, and it will be 6 times A divided by 1,000. If we just add these two, we're going to end up with minus 6 times 185 divided by 1,000. So the moment of these two 6 kilonewton forces, it's going to be minus 6 times 185 divided by 1,000. And the last one is the moment of the 16 kilonewton. The moment is counterclockwise, and if we want to find the distance, we have the distance from A to the line of action, which will be 125 plus 30. So the moment is clockwise, so plus 16 times 125 plus 30, again divided by 1,000 in order to get it in meter. And the last one is the moment that we are trying to find, or our bending moment MA. We consider that one counterclockwise, so positive. equals 0. So our MA would be negative of what we have in here. So minus 23 times 165 divided by 1000 minus 6 times 0.185 plus 16 times 150 0.155. So the MA would be negative 2.425. So we'll be positive for 25. We did not get any negative sign. That shows the moment was actually counterclockwise. So kilonewton meter, and the moment would be counterclockwise, and that would be the last things that we need to figure out in this question, or the bending moment. So yeah, hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.